Hi everyone, I'm Mrs. Wenmaker, and on behalf of all of the Algebra 2 teachers at Wheaton North, I am going to do a mini lesson on quotients of functions today. So your assignment today is to follow along with this video with the guided notes that we have posted. Now, if you can print the guided notes, great. If not, you're just going to do the problems that we're doing together and the ones that are on the worksheet just on some notebook paper or any blank paper, and then you'll submit that as your assignment for tomorrow night. Now, the first thing on that assignment, if you haven't already, is there is a little bit of a warm-up. So if you want to go ahead and pause me for a moment and try those two problems if you haven't already, now would be a good time. If you've already done those, then we're going to dive into quotients. So we've already done adding and subtracting, multiplying, and last we have dividing of functions. So before we really get into the quotients, the first thing I want to talk to you about is what are some math no-nos? So like something that we're not allowed to do in math. And you may be like, I don't know what you're talking about, and I don't want to even think about it. But for an example, more recently, we saw that we cannot take the square root of a negative number, right? Like that, there's no solution. There's no such thing as a square root of negative 64. That just doesn't work. So that would be a math no-no. Similarly, if you were to try to type in your calculator something like 17 divided by 0, what would your calculator say? I happen to have my handy dandy calculator here with me. If I say 17 divided by 0, let's see if we can show you that there. It says error, dividing by 0. It doesn't let us divide by 0. That's impossible. It's saying take these 17, let's say, dollars I have and split it into 0 people. Like just make the money disappear. It's like some sort of weird magic. That doesn't happen. So we can't divide by 0. That's another math no-no, and that's going to be the one that we're going to be focusing on today, because when we are dividing functions, we just have to make sure that we don't have 0 in our denominator ever, because that's not possible. It's not possible. Now, what does that look like on a graph? When we are talking about functions, those have graphs, so we might be looking at some function like this. This looks like some sort of maybe cubic function that we have, and when we first look at it, it just looks like it goes on and on forever in both directions. But if we look really closely, okay, I'm going to zoom in again here. If we get really close, do you see right above where the x value is -5 that there's like this little tiny hole in the graph? That would be a spot that we would call an excluded value. At that particular point, okay, right here, let's see if we can find it right there, that point has a value of x that isn't actually defined. The graph makes a little jump right there because it doesn't work. So in this particular case, we'd say here is our function, but we're just going to have to make note that x cannot equal -5 in that function. So that's kind of what we're going to be leading into, looking for these excluded values. So take a moment on your notes and let's just write down this definition. What is an excluded value? So an excluded value is an x value that would make the denominator equal 0. So it's specifically the denominator that we're worried about equaling 0. You can have a numerator of 0. If you try typing in your calculator something like 0 divided by 7, you just get 0. If you have $0 and you want to split it among 7 people, everyone just gets $0. That's fine. Again, the problem is only if you were to try to have $7 and split it among no people, that would be making it totally disappear. That's the problem that we cannot do. That's impossible. Okay? I am not used to writing on this little whiteboard and I run out of room very quickly. All right, so we are going to be dividing functions today and then looking for, looking for our excluded values. So what I have for us as we talk about quotients is I just have a bunch of different functions. So we've got f of x, g of x, we've got all these different functions, and we're going to look at a few examples together, okay? And again, you're going to be writing these examples down on your notes as we go along. So let's say that our first question said, what is let's say f of x divided by g of x. So that was the question. What is f of x divided by g of x? You're literally just going to look through your list of functions and find f of x and find g of x. And it's asking us to divide them. So f of x divided by g of x, the first part of our answer is literally just writing these on top of each other. Lucky for you, we are not going to do any sort of long division or anything crazy. That is f of x over g of x. So it starts off super simple. You just write the one function above the other, whichever one it tells you to do first and second. But then the second part of that is where we're saying excluded values. So there are, not in every single problem, but often values of x that might make the denominator 0. Okay, keep in mind we're only focused on the denominator. So if our denominator were to be 0, then this function would not be defined at that point. And so we just have to say which, after this, I'm just going to put a comma and say which values of x can x not be? Which ones can we not use for x? So again, only focus on the denominator. We don't care about the numerator. The numerator could be 0, the numerator could be negative, could be positive, it could be a decimal, it could be anything. But we're going to focus on the denominator. So I want you to think to yourself, what value of x right here would make that denominator 0? Okay, and that answer would be -5, right? If we put a -5 in here plus +5, those would become 0. And so that's the only value of x for our problem that is excluded. So our answer has kind of two parts. It's all of this. It's us writing the one function above the other, and then additionally excluding some values from there. All right, let's try another one. What is, let's do p of x over h of x. Okay, p of x over h of x. So you're gonna look for those two functions, p of x and h of x. Okay, so p of x over h of x. 2x minus 1 over 7. That is our function. That is our answer. But we have to just decide, are there any excluded values? What values could we put in for x that would make the denominator 0? But when you look at your denominator, there are no x's there. So in this case, there are no excluded values. If there are no excluded values, if there are no x's in the denominator, then there's no way that the denominator could change, because this is not a variable. That's a constant denominator. It's staying 7. It's never going to become 0. You could put any number in for x, any number that you can ever think of, it's going to be fine in here. Okay, so there are occasions that there are no excluded values. But if we were to have an x in that bottom function, then we have to worry about excluding. Okay, so let's do another one where we're actually going to be excluding this time. How about, we'll change this to g of x over k of x. So again, just starting with writing those two, g of x and k of x. So the first step is writing one above the other, g of x over k of x. We have an x in our denominator, so that means we are going to have some excluded values or values. It could be 1, could be 2, depending on the problem. So what we're going to do to determine what those excluded values are we want to see when would our denominator equal 0. So basically off to the side, you're just going to set that second function, the one that was in the denominator, equal to 0. We could divide the 3 away. 0 divided by 3 is still just 0. So what value squared makes 0? Well, that is just 0. So in this particular case, x cannot be 0. X could be any other number that exists, but it couldn't be 0. And so that would be our answer. Here is our function. As long as x isn't 0, it is a real function, and it has points at every part of that graph, except when x is 0, there's a little gap, like we talked about on that at the beginning of the video. Okay, I'm going to do one where maybe it gets a little bit more complex figuring out that denominator. Let's say that we had h of x over f of x. Okay, so h of x, f of x. And when we have this function and we look at our denominator, we see that we have a what we call quadratic, right? So there are x's in the denominator, so we know we are going to have to list some values that x is not allowed to be. And what we're going to do to figure that out is off to the side, we're going to set that second function equal to 0, and we have to find out which values of x would make that equal to 0. So when you have a quadratic, we're going to factor. We're going to think what two numbers multiply to make -8, but those same two numbers have to add up to make -2. So those numbers would be 4 times 2, and we need to figure out the sign. So if we want a -2, we want more negatives and less positives. But now again, we're solving these to find out what x actually can't be. So if we were to solve this equation, I'll cover this one up. If we were to solve this little equation that x plus 2 equals 0, well then x would equal -2. Over here, we would add the 4 over. So these two values that would make 0 here are the ones that we're actually going to exclude. So x cannot be 4, x cannot be -2. If x is either of these two numbers, 4 or -2, then this function isn't really a function of that single point. And so that is our final answer. All right, so you have a couple examples that we've gone through together. As you're going to see on the notes worksheet, there are 2 more that we're going to ask you to try on your own. If you, for any reason, are having trouble with this video didn't make sense, you have Miss Martin or Miss Propolis or something and they explain things so much better, that's fine. Just reach out to us and we're happy to meet with you one-on-one or set up a Google Hangout. We're here for you. We want you to understand this. So just let us know if we can be of any assistance, okay? Thanks for listening. Finish up that notes worksheet and then you're going to submit photos to us online. All right, bye guys.